Okay, we are expected to integrate this question. Now what I wish to do is, let me take this as I equal to. Now this is the greatest integer function. Now since x is constant in the interval 1 less than equal to x less than equal to 2, I can take this greatest integer function of x to be equal to 1. So therefore we have 3 times of e negative 1 divided by e limits 1 to 2 x squared times e raised to the power of 1 positive x to the power of 3 times the dx. Now a raised to the power of n positive m is equal to a raised to the power of n times a raised to the power of m. So this is going to be rewritten as 3 times of e negative 1 divided by e limits 1 to 2 x squared times e raised to the power of x to the power of 3 greatest integer times dx. So e is a constant, so it can be taken out. So 3 times of e negative 1 times e divided by e limits 1 to 2 x squared times e raised to the power of greatest integer function of x to the power of 3 times dx. E gets cancelled. Now I wish to take x to the power of 3 to be equal to some t. So 3 times x squared dx is equal to dt. So x squared dx is equal to dt divided by 3. So when x is equal to 1, t is equal to 1. When x is equal to 2, t is equal to 8. So the new limits is going to be 3 times of e negative 1. Limits are 1 to 8. X to the power of 2 times the dx. That is going to give me dt over 3. 3 is written here. Now e raised to the power of x to the power of 3 is t. So greatest integer function of t. So this is going to be 3 times of e negative 1. In fact the 3 can be cancelled, so we are going to just have e negative 1 times, the limits are 1 to 8, so I'm going to split it as 1 to 2 e raised to the power of t times dt plus 2 to 3 e raised to the power of t, of course greatest integer function, dt plus etc. Now 7 to 8 of e raised to the power of t times dt. So this is how it looks. So this is going to be equal to e negative 1. Now 1 to 2, the greatest integer function is going to be 1 there. So I'm going to get e there, right? So if I were to integrate these quantities, the first term will give me e, second term will give me, this is e raised to the power of 2, right, between 2 to 3. So the third term is e raised to the power of 3, and I will have to stretch all the way. This is going to be e raised to the power of 4 plus etc. all the way, right? The last term is going to be 7 to 8. So this is going to be e raised to the power of 7. Now this quantity is obtained after the integration, because we are going to have a t, right, integral dt, and the limits are 7 to 8. So whenever you apply the limits, you are going to get a product multiple of 1. So that is the reason I'm directly writing it like this. Now if I were to take e out, this is going to be e negative 1 times e of 1 positive e squared plus etc. up to e raised to the power of 6. Now I'm going to utilize the summation formula, which is a times of r raised to the power of n negative 1 divided by r negative 1, with a being equal to 1 and r being equal to e and n being total number of terms being equal to 7, right? So if you were to substitute that, this is e negative 1 times e times 1 times e raised to the power of 7 negative 1 divided by e negative 1. So e negative 1 gets cancelled, giving me e of e raised to the power of 7 negative 1. Okay, so if you want to distribute that, you are going to get e raised to the power of 8 negative e. So this is the solution to this question. So having got that, we'll move on to the next one.